Welcome to the last lesson in the polynomials unit, and we're going to cover practical applications today, more so on volume and area type questions. For example 1, we have a piece of sheet metal that's 25 by 18 centimeters, and we use it to make a box with no lid. So this is the shape that we're looking at here, a box with no lid. Okay, and then it says equal squares of side length x centimeters are cut from the corners and the sides are folded up. So it basically describes how this box is going to be created. We have a sheet of metal and we know that it's 25 by 18. Then we're going to cut x centimeters of squares out, so the length and the width is a value of x. We're going to cut this section out of our sheet of metal, and we're going to do that for every corner. Now this is what's left over then. It's going to be this region in here that's left over. And then it says the sides are folded up. So here are the creases to fold up those sides to create that box. Basically, I'm looking at an unfolded version of this box, looking from the top down. Now we know that volume is generally calculated as length times width times height when we're given a rectangular prism. So that's what we need to find. We need to find the length, the width, and the height represented in here. So I'm going to read off to see what the height of this is going to be. So this is 18 minus, and we know the length here is x, and this is x as well. So we have two of those, so this is 18 minus 2x. That is our length. And our width is from here to here. And that's going to be the similar concept, 25 minus these two little x's on each side. So this is 25 minus 2x. So our length can be 18 minus 2x. Our width can be 25 minus 2x. Those are interchangeable. You can call this width, you can call this length, it doesn't really matter. And then our height, so if we were to fold this up, this would be our height in here. So that's x. So again, our x would be the height of our box, which can be found by our square cutout. This is the function for the volume. Now it says graph the function and state its domain. We are going to graph this in terms of our scenario. So I'm not going to graph the entire graph because certain numbers wouldn't make sense. For example, if x was -1, that means our entire volume of the box is -1, and that doesn't really make sense considering it's a box that we can actually put something into. The volume needs to be bigger than 0. So we're going to start off by graphing kind of the same way. We're going to think about the zeros of this using our multiplicity method. So your zeros are 0 from the x here, and then from 18 minus 2x, that's going to be 9. From 25 minus 2x, that is going to be 25 over 2, which is 12.5. Those are our three zeros. But if you notice, if you take 12.5 and plug it into this function over here, this part of our function, 18 minus 2 times 25, 18 minus 2 times 12.5, we're going to get a negative number. So we get a negative length. Which again doesn't make sense with our context. So this one we're just going to get rid of. We're not going to use it. So the only zeros we're going to consider is 0 itself and 9. So 9 will be about here. We also know this volume is going to be positive, because if it isn't, well, then we can't use this. But we're going to check. So we can create a mini sign diagram from 0 to 9. And we can plug in any value in here. Let's just say 2 and see if it's positive or negative. It should be positive. So if we did 18 minus 2 times 2, that's positive. 25 minus 2 times 2 is also positive, and 2 is positive. So that means that this whole region here will be positive. And don't really care about the scale because I just want to show the shape. So that would be it for our graph. Now we want to find its domain. Now your domain here, should we have really included the 0 and the 9? Well, if we did, that means one of our lengths is 0. Or if it's 9 again, 18 minus 2 times 9, this whole thing is going to be 0. So really we shouldn't include this because it's not really a box if you have a volume of 0. So I'm going to make them into holes now instead. So our domain is actually from 0 to 9, not including 0 and 9. Here's another example. We have a rectangular field that's twice as long as it is wide. So I'm just going to draw this out. So we know the width, and we know that the length is 2 times its width. This is going to be your original field. Now we have another one that says 3 feet are taken from the width and 4 feet is taken from the length. And the resultant of the field, area of the field, is 180 feet squared. And we want to find the area of the original field. So we need to figure out what our width is in order to figure out the area of the original field. So our goal is to find what W is. And we're going to use information about this new one, which I can draw. It's going to be a smaller one, because you're going to take 3 feet from the width and 4 feet from the length. So if I want to find the area of this is 2W minus 4 multiplied by W minus 3, and this should be equal to 180. So that's length times width is our area. Now I'm going to expand and simplify and solve for W. So 2W squared, then we have 2W times negative 3, negative 4 times 4, negative 4 times negative 3. Going to rearrange and collect my like terms. Sorry, these are supposed to be W's. And then I'm going to factor the 2 out. I know that 12 times 7 gives me 84, and I can get a negative 5 if I had a negative 12 and a positive 7. So W then is either 12 or negative 7. Again, we have to think about our situation here. Does negative 7 make sense as an actual length? It doesn't, so that can't be our width at all. So it has to be 12. Now, we're not done. We just found the width. We want to find the area of the original field. So we want to find the area of this. That's 2W times W, which is 2W squared. We just solved for W. We know that is 12. So that's 2 times 12 squared, which is 2 times 144, and that is 288. On the next page, you're going to have 2 try it yourselves, so please try those questions on your own. They're very similar to example 1 and 2. Use that as your guideline, and then when you're ready, press play. Okay, so here's the solution to the try it yourself. This question is very similar to the first example, and it's the same diagram. You just need to change your numbers to 30 and 25 for your length and your width. And same thing, you're going to subtract a length of x on each side to get your new length. Now when you're graphing this, you're going to get zeros of 0, 15, and 12.5. But if you plug in the 15, you're going to get a negative volume or also a negative length, which makes no sense. So that's why we discard the 15 and just focus on 0 and 12.5 as our zeros. And then when you graph it, this should be, again, above the x-axis because we need a positive volume. And you could also do a sign diagram to check. And your domain, we're not going to include 0 and 12.5 because if we do, we'll have 0 length, which doesn't really help us for a question like this. Just an example, if you ever need to find the maximum volume, usually at this stage we just need a graphing calculator for that, but you can approximate it a bit. So this one, for example, would be around 6, because that would be where your max is located, around here. So if you want to find your maximum volume, you're just going to plug in x equals 6 into your volume polynomial to figure out what the volume would be. So it's not like precisely at 6, it's going to be 6 point something, but you can approximate it. And lastly, for either try it yourself, again, it's very similar to the other one. You would probably want to draw a diagram to help you out. And in this case, we have a field that is 4 times as long as it is wide. And then we're going to take 2 away from the width and 4 away from the length. And then we know this area of the field is 24. So that's how I set it up right here. Again, you want to multiply out and then rearrange your polynomial so everything is onto one side, and then you're solving for w, which is your width. When you do that, you're going to get 4 and negative 1. Again, we probably want to discard the negative 1 because if we plug it back into our w minus 2 or our 4w minus 4, we will get a negative length or width. And we don't want that. So I discarded that, and we're only going to use w equals 4. So you're going to plug that into the area of the original, which is 4w times w from here, which is the same thing as saying 4w squared. That's 4 times 16, and your final answer is 64 feet squared.